This video is for the assignment of switching systems architecture course. In this video, I'd like to tell you about some main points of the lecture of week 5, which is about optical switching. In recent years, optic fiber is widely used in telecommunication field. Fiber consists of glass core and cladding, as the light can be guided within the core due to internal reflection. Besides some advantages such as good insulation and the resistance to electromagnetic noise, its greatest advantage is low attenuation for wide bandwidth. According to total attenuation curve shown on the slide, optical loss is less than 1 dB per kilometer, between 1.2 micrometer and 1.7 micrometer, and the bandwidth is around tens of terahertz. Next, let's move on to wavelength division multiplexing technology. In this system, transmitters provide stable light within specific narrow bandwidth. Then combiners can combine these signals, and optic fibers can exhibit low loss transmit signals within several channels. This loss is dependent on the number of channels, but can be mitigated with optical amplifiers, such as erbium-doped fiber amplifiers. Finally, the multiplexed signals will be separated out by splitter. Here I'd like to point out that noise will also be amplified by amplifier, and there will be power loss due to broad splitting. Compared with fiber network using electronic switching, our optical networks have some benefits, including high transmission speed, low cost, lower power consumption, and transparency. However, in optical networks, analog signals and noise will be amplified at the same time, and it's hard to monitor error rate. Now we have known some features of optical networks. The next question is, where are optical networks used? In terms of access networks, passive optical network is a major utilization. Passive optical networks use passive splitters in the fiber distribution network, enabling one single feeding fiber from the provider's central office to serve multiple rooms and small business. Compared with traditional networks, it has fewer transceivers and higher efficiency. Next, microelectromechanical system is a kind of all-wavelength switching, which is based on precise positioning of mirrors and integrate mechanical system and with control electronics. Next, I'd like to briefly introduce some optical multiplexing and demultiplexing technologies. In terms of multiplexing, optical add-drop multiplexer is most common, which can add and drop wavelengths. In terms of demultiplexing, we can use refraction, diffraction, and interference to separate light of different wavelengths. Another important component in an optical network is interferometer. It is a device which can determine relative phase of combined wavelengths by changing delay element. When there is 180-degree phase difference, we will get nothing at the output of combiner. By using splitters, filters, and combiners, we can build a simple switch like this. This slide shows the design of an electro-optic control system, which can be used to detect the arrival of packets, process packets, and control switching according to control information. In this system, payload can travel over light paths from source to destination, while control information may incur optoelectronic conversion, may even flow an electronic control network. When it comes to optical buffering, we can use long loops of fiber to form delay lines, but we need to consider attenuation in delay lines and how to implement variable delays. Both programmable fiber delay line and active recirculating delay line can control the holding time, but they also cause loss and noise. Another solution for contention is in space domain, which is deflection routing, which means some inputs will be routed on shortest paths, while others may be deflected on longer paths to avoid contention, but it will reduce throughput and cause mis-sequence. Let's find some differences between electronic and optical networks. In terms of processing, electronic network is more suitable for packet switching, while optical network is more suitable for circuit switching. In terms of buffering, packets are forwarded on shortest paths in electronic network, while packets may be deflected in optical network.